Hi, good morning, everyone. This session will be talking about the memory profiler. Uh, would it be okay if I request you to come forward, or it will be easier for me? Thanks a lot. Sorry for this. So, thanks. So let me start this presentation with this story. So when my two sessions uh, got selected for the PUG, company handed over me a credit card. Okay. Says, Sunil, whatever expenses you have for this trip, use this credit card. Okay. So for my visa, for my accommodation, for my flight tickets, I use that credit card. So far, it's very good for me. I don't have to pay anything from my pocket. Everything is covered by my company's credit card. Things fine. Now, the frictional part and this thing I don't want to get into. I went back and handed over that credit card to the company. Say, we'll take care of the bill. After 15 days, my manager comes back to me and says, Sunil, we can't pay your full credit card bill. I asked, why? You provided me bill, whatever the expenses are there. I use that credit card for that bill. Why? So it's over the limit. So I asked question that, how much is the over limit? It says it's 30% over the limit. I got surprised. The way I have spent the money, it should be less than the 30% of my limit, but it's more than 30% of my limit. So ask a question. So what is the obvious question should I ask? Tell me the bill. Show me the bill. What are the bills? Show me where I have spent the money. And the answer is, we don't have a bill. I can't tell you, manager told me, I can't tell you whether you have used that bill, that amount, for the expensive dinner, or it's some fraud happened with you. So I don't have that information with me. And you might be facing the similar situation when you are dealing the performance problem with the OpenEdge application. You assume that your application or your system should consume X amount of memory or X amount of resources, but when you actually see on the system, it's more than that. Then you ask OpenEdge a question that, show me the bill where I am consuming all my memory. And guess what OpenEdge says? I don't have a detailed bill for you. I can't tell you that you are consuming this byte for what and this byte was what. Whether you are actually using that memory for the expensive object, expensive dinner, or you have a credit card fraud, or you have memory leak in your system. So that was the question that we were getting always, that whether it's a memory leak or the genuine object. And with the tool, we are trying to address that problem, that do you have a memory leak on your system? So that's the reason behind why we funded that project. Now, if I go in a little bit detail of it, this is just for the information. So whatever we are covering in this presentation is for the information. It should not be considered as a commitment from the progress. So a little bit disclaimer. Okay. So with that story, that was the reason for why Progress funded that project. This is the agenda for our presentation. We will be going through some motivation why we have a memory profiler project with us, some understanding of how AVM uses the memory. Then we will go into a quick demo. Demo is just showing a few various documents. And then we will discuss about the architecture and memory profiler. Okay. So with that, let me go to the next slide. Now, understanding of this problem. So part of it I have covered in the introductory part with my example. Now, when OpenEdge is a reliable thing, okay? Many of the things are covered by the language. Many of the administrative things are covered by the platform itself. So when everything works fine, you have a piece, you can easily work with your application, you don't have much to do with your configuration, I think. But it will give you a really hard time when it comes to the performance problem. And how do we know this thing? So when we analyzed our record, that how much we have invested in our tech support or with our tech support to the performance-related issues is a huge investment. Whenever we get any ticket that talks about the performance or memory-related issues, there are many back and front between the tech support with the customer and the huge time involved in that. So we analyze that, okay, in whatever tickets we have got, huge amount of time getting into the memory-related problem. So that why these things are not being solved by the existing things. So we have a CPU profiler. Many of our customers use the CPU profiler. But the CPU profiler is different than the memory profiling. CPU gives you about how much time it takes to run your thing. While what we are looking at a memory profiler, when we are looking at a memory-related issues, we need to answer a space-related problems. So though we have a CPU profiler since long in our system, but that is not helping at all. That is not helping too much when we are dealing with the memory-related issues. So while analyzing this thing, we thought we should be investing on this problem. And it is not that we have not addressed this problem in the past. In the past, we have provided dynamic object logging. That gives you some information about how many dynamic objects that you are creating in the system, when they created, when they deleted. So a dynamic object has some information about it. We have a past monitoring, JMX thing. JMX gives you the information about how much memory is currently being consumed by the PaaS server. And we have a pulse monitoring tool. You might have heard about the Iceberg project, which is available in the Git repository. That gives you a bunch of tools that give you input or insight into what's happening in your PaaS server. But together, all of things, they are not sufficient enough. We needed, or our customer needed, a dedicated tool that will only focus on the memory-related stuff. And that's why we went ahead and started investing in the memory profiler project. Now let's see, when we talk about the memory, where all the memory is going in when you are running ABL application. So when you start the AVM, when you start through the PaaS or through our normal GUI or GUI client, okay. So when the AVM starts its working, it needed some memory to its functioning. And that memory is divided into two parts, a platform memory and the application memory. A platform memory is those things that it needed to do its functioning. So when I start the AVM, we provide a couple of startup parameters. One is BT, that says what's my timetable buffer pool, my runtime stack, R code memory, directory entries. So these are the initial configuration parameters that you are configuring in the AVM that says, okay, this much memory you needed for its functioning, to AVM to run its functional job. Now the next set of memory is needed for the application. So that is, when you run any R code or when you run any procedure, that R code or procedure is asking for some memory. Okay. So when you load a P code when AVM loads the P code, it requires some memory. Okay. When AVM creates any object, so at that time it requires memory. So these are the memory application is requesting AVM to create it for it. Now, OABL object, .NET object, dynamic queries. These are at the runtime when our code executes. Okay, you are requesting to the AVM allocate this much memory for this object. So there are two types of memory that AVM currently manages: a platform memory and the application memory. Platform memory, that is, it needed to do its job, and the application memory, the application needed to perform its jobs. There are two sets of memory. And then with this memory, what are the unanswered questions at present we have? So obvious questions. Why is my application leaking memory? So if I have to answer this question, so first of all, where in the system my application is leaking the memory? Okay. So when I visited the Prague, various places, where did I use that credit card which resulted into a problem? So what information I needed? I needed which place I went, how much money I have spent it over there, and what are the entire transaction that. Similarly, when we are working with the AVM, when we want to answer this question, where is my application leaking in memory? The other question inherently, that is, where is all memory going? So where all my transactions are happening, where have I spent all those money? So in similar way, where all my memory is being allocated in the system. So to answer that question, the next question where I will be asking to the AVM, what got allocated? Okay. Where was it allocated? When got allocated, and how big it is. So what got allocated? That means whether I'm creating any ABL object, .NET object, or I'm making any database connection. On that database connection, I am executing any dynamic query. So what type of object that I am creating? Where it is got allocated. So I might be creating a dynamic object or my dynamic query in 10 places in my code. So where in my code I am creating that dynamic query object. The third part is when it was got allocated. I might have a recursive function. I might be coming to that call again and again. So at which call this memory got allocated? I might be running a PaaS application, and I'm getting 10 requests on my PaaS application. So which request has created that dynamic object? So when it got allocated, and the last is how big it got allocated. So when I'm creating any query for the small table or for the one type of object in one call for the similar place, I'm allocating certain amount of bytes, suppose 10 bytes. But same place for the other request, I might have to allocate 100 bytes or 1 megabyte. So how big is that? So all this transaction information, all this memory-related information, we need to address. So at present, these are the unanswered questions we have. Now, to address all these questions, we need a lots of data. Now, to this data, now what data we needed? So those are the questions at present we have in hand. Okay. To answer those questions, we needed a data, and what data we needed for that. Okay? So every single application object that you are creating in your application, that is either a .p procedure, OABL object, dynamic connection, dynamic query, anything. Okay? Whatever you are doing in your application, for that, the AVM internally has to track what each object is. So whether I'm creating a query object, I am creating any built-in object, or I am creating any UI object. So that I need to track in the AVM. While I'm creating that object, I need to look how much memory it is in. And if it's that object is runtime growing in the memory, I need to also keep track of how much memory is being grown at which portion in the time. When it get created, and where is created. So when it got created time, and in my call stack, where it got created. And the top of it, that is the creation part, that is all the memory. But after this object get created, at certain point of time, it should get removed from the system. When it should get removed from the system, that is the scope of that object. So also I need to keep track of where that object is scoped. It is particular that block, that bigger object, or the entire procedure, or this object is a part of the entire session. So all this data I need to keep track in the AVM so that I could answer all the questions that I have in my previous slide. Okay. So far we have seen that what are the different memory, platform, application memory, what are the unanswered questions, that is where it got allocated, how it got allocated, everything. And the third part is to answer those questions, what data we needed. Now let's see those things in the memory profiler view. So we have what data, where, and how. Now the next part is, what are the processes we are targeting through a memory profiler? So in our OpenEdge ecosystem, we have various processes. Either those processes are single-threaded or a multi-threaded processes. So for in the first these three processes, that is my AVM, my underscore progress client, that is my GUI client, my Provine GUI client, or my batch mode client. So these three clients are the single-threaded applications, single-threaded processes. The next client that I have is my multi-session PASOE agent. Now, this process is multi-threaded process. So each of these processes have a multiple threads in it. Now, every thread, either it is single-threaded process or a multi-threaded process, each thread is associated with one ABL session. So whether I am working with a single-threaded process or multi-threaded process, at the end, what I need to track is what's happening inside that ABM sessions. So everything will boil down to the ABL session. Now let's see in the ABL session what's happening. So my PASOE agent or a single-threaded sessions, I have a AVM sessions, and when I'm tracking my AVM, in the AVM, what I am tracking the AVM ABL session. So for the ABL session, we have a various scope associated with it. Now, when I'm executing the .p procedure, so that .p procedure is executed in the scope of ABL session. So whatever memory has been allocated, that allocated is for that session scope. Now, inside that procedure, if I am creating a temp table or if I am creating any query object, so that query object and everything is scoped to that procedure. So when that procedure is done, everything which is got allocated to that procedure should get removed, should get out of the scope, and should be garbage collected and removed from the system. Same way is for the OABL object. If you are creating an OABL object, then it is scoped to your session. If you are making any database connection from that ABL session, so that is scope for that ABL session. And on that, the last part is the server connection. So whatever server connection you are making, all those server connections are a part of that ABL session. Now, beneath that thing, we are providing option of a widget pool, name and the unnamed widget pool. So if we are creating any UI object, that UI object comes from that widget pool. So when I'm tracking those objects, I need to track that it is created from which widget pool object. And when I'm going out of scope, from where I need to remove from that memory or from where I need to subtract that memory. So these are the various in the ABL session, these are the various things that the memory profiler tool has to keep track of. Now, if you don't have any widget pool associated with you, then I need to go one layer up. Suppose you are executing a 3-level or 4-level nested call in the procedure, nested procedure call, and none of the places you have created any widget pool, named or unnamed. And at the 3rd level, you are creating some UI object. So when that UI object gets created, if you don't specify any widget pool for that, then it will go up in the hierarchy. Do my parent has any widget pool? If it's not that, then at the end, it will go to the ABL session. And by default, every ABL session has one unnamed widget pool associated with it. So finally, I don't have any widget pool in my hierarchy, so I will use that unnamed widget pool to allocate a memory for this UI object. So this is how the memory is being scoped in the ABL session. So that is the memory that is being allocated in the ABM session. Now, what the memory profiler is doing behind the scene to track all those things. So in the memory profiler, the memory profile is kind of running movie. If you are creating any OABL object, whenever you are creating that object, it says, okay, this object is created with this much memory. And if you are an active developer, you will use a delete statement for that object. So when the delete statement is used for that object is marked for the garbage collection. And whenever the garbage collection runs, it will remove that object. But somehow, if you forget to put the delete statement for your dynamic object, then whenever that object gets out of the scope, at that time, it gets marked for the garbage collection. And when the garbage collection kicks in, it will remove that object. So all this recording is happening behind the scene in the AVM. So that is data collection part of the memory profiler. The next part that is important is the data reporting part of it. So I have collected all the data, but when we are playing a movie is a collection of frames. The same way, when I'm reporting the memory from the AVM, that reporting is those frames. I'm saying, and that those frames are represented as a snapshot. At a given snapshot, what are the objects which are live in my system? In the given, when we are playing a movie, when we see a frame, in that frame, what are the characters which are active in that frame? So it's okay, these are the characters which are there in that frame. The same way, in the memory snapshot, we'll say, okay, what are the objects which are alive or what have been created in this frame? So when we report anything, we'll say, okay, what are the things that has been happened in that snapshot? So profiling data is a running movie. It will keep on collecting a data. At certain time interval, it will keep on putting that data into the report. So this things happens in the background. Now, for that, what we have provided in the language, we'll see the things in the quick demo sort of thing. What we have provided the startup parameter. So whenever you are starting your application, you will start with that application, that startup parameter. That startup parameter is a configuration for your memory profiler. That says that whatever snapshot, whatever reporting you need to be done, where that reporting need to be done, and how often we need to do that reporting. Then there is a language extension. So that if I say that you report it every 2 seconds, you report it every 5 seconds, that's one way of configuration. But say I'm doing in my development environment, I know that which code area has some trouble. I need to dig down in that code area. So language has provided the option, you take a snapshot beginning at some point of time in the code, and take another snapshot somewhere in some other part of your code. And you compare these two snapshots to understand what's happening inside these two snapshots. So for that, language has provided the extension. And all the reporting is being done through these snapshot files. So these are the various extensions we did in the language and the AVM to work with the memory profiler tool. Now let's see those things into a demo or a screen share. Let me walk you through this ABL code. Okay. So what we are doing in this code, we are defining these two call objects. Oh, sorry. So let's go through this .p file. Okay. So in this p file, what we are creating, we are defining two variables. These are the handles. Okay. And at line number 15 and 16, we are creating these two call objects. Okay. Later on, what we are doing with this call object is we are telling that, okay, call object 1, you go ahead and execute hello.p. define this is procedure call type, invoke. Go ahead, execute this thing. Second, with the call object 2, we tell that, okay, you use this persistent.p, okay, and execute this time. But this time we are telling him it's a persistent. So after executing, you need to do something with that .p. Later, inside that persistent.p, I have an internal procedure. So I'm invoking over there. Okay? If you keep track of your memory, you will put this delete statement in the system. And somehow you may forget to delete statement to simulate those two scenarios. In one case, when I'm executing first time, I will be having this delete statement with me. That is kind of everything is good. I have created something. I know what I have created. I'm cleaning it up. Second scenario, it's okay. Somehow, I forget to put the delete statement in my statement. So what will? So if I forget, I have created something, and I forget to delete that thing, that is persistent. So what will happen? So that is something in my system. So that is something that we should not be doing, but we did that thing. Now that's the .p file. And then we decorated this .p file with some profiling function. So I am using the memory progress.profiler. This is the built-in stuff. In this class, or in this system handle, we have provided take snapshot. So what take snapshot will do, at that point of time, whatever is the state of ABM, it will go and report it as in one snapshot. So at this point in time, we took what is the state of the system, go and report that thing. Then we have created our object. So we did some work, and say, okay, take another snapshot. So after that, we took another snapshot. So we have a one snapshot, we have a second snapshot with us. Then we perform some other task. At the end, we took the third snapshot. So we have an initial state of the system, we did some work, and that at the end, we took the another state of the system. So now we have a three state of our system, and we could compare this three state and try to see what's happening inside this three state. Now in the one scenario, where we have this delete statement, it should show me that when I am done, I should not have those objects in my system. They should be gone from my system because I have deleted them. If I don't have this thing, then the AVM still have those objects alive in it. So that is kind of memory leak in your system. Now, in the reporting part, we need to see how we are reporting this memory leak to you. So this is very simple, basic case where you forget to delete the things. Now, memory profiler is up and running, and how memory profiler will detect that thing and report to you. Okay. Now, for that, I'm showing you these two files. So we discussed that we create a snapshot, and that snapshot is a representation of what's happening inside the AVM. Okay. So this snapshot file is kind of divided into various sections. So the initial section, this tells you information about what are the platform memory that you will be observing or we will be reporting in the AVM. So the first part, that is line number 3 to line number 22, that's a platform thing. Whatever, how much is being consumed in my BT, how much I'm consuming it in my CPU profiler, all that part. The next part, that is 25 onwards, what are the application objects that the ABL memory profiler is able to track? So these are all the objects that we'll be able to track. And the last part, this part is, what are the built-in classes that we are able to track? So all the application objects, built-in objects, this is the initial catalog has been provided in this file. So all these things being tracked in the system. And then the next section starts various snapshots. So this OEMP file is the entire file which has a collection of snapshot. So if I go back here, that pre-snapshot, so we use in our code take snapshot pre. So at this point of time, so line number 13, when the AVM is executing this .p file, at the line number 13, what is the state of the AVM that has been represented by this snapshot? And these are all numbers. Okay, now you need to make a meaning out of this number. Okay, so we'll go and see this after snapshot. That is, at line number 18, I am taking after snapshot. So at that time, what I have created? I have created two objects. So how could I see those two objects? This is object number 4, object number 5, and its type is 50. So let me see what is 50. Now 50 is my call object. So it says that object number 4 is of type 50, which is call object. And object number 5 is my call object. In the pre part, okay, and then it says where it got created. So it got created at module 1, line number 15. So it got created at 15 and 16. So this is how the creation part is being kept into the in my OEMP file. The next thing is the deletion part. So if I go ahead, check my done part, okay. So at my done part, I have this object number 5 and 4 in the delete section. So first of all, my catalog, then how many application objects I have created. So this section of my memory says that what is the platform memory is being currently consumed, and this part says that what are the application objects I have deleted at that point of time. So if I see that in my delete snapshot, in my done snapshot, if I am deleting that thing, then those objects should be recorded at the time of done snapshot. So at this case, in this OEMP file, where the delete statements are there, in the done snapshot, I have these two objects deleted for me. But in the other scenario, in this case, where I don't have the delete statement with me, if I am going to my done statement, I don't have this 4 and 5 object in my delete section. Where they are reported? They are reported way back when I am exiting from the system. So it says when this AVM session is this process, when it is exiting, at that time, as a cleanup part, AVM removes those objects from the system. That means developer forget to put a delete statement in the call. That's why they will remain in the system till the time this AVM session will go out of, when AVM session terminates itself. So that is the indication of memory leak in the system. Now, all these things are numbers. And if you have been there in the presentation which is given by the Patrice on the practice from Progenode, they have developed their own tool consuming this OEMP file to report where are the memory leaks in their system. So not all the customers will be having that facility to go ahead and build their own system. So this was the reporting part. And the next section, I'll be covering that how Progress is planning to report this thing as an UI tool. So this is how we have been collecting the data. This is the interpretation of the data. And the next section will cover how we are representing data in terms as a one tool instead of you going ahead and just playing with this number. Because it is hard. For the simple application, there are so many numbers, it is hard to keep track of what's going where. So to make this to make the developer's life easy, we will be providing the tool to visualize the profiling data. So now let me go back to the presentation. So let me talk a little bit about the architecture of the profiler tool that we are developing. So it has a 3 component in it. This section is the ABL application that you have, is either a single-threaded or multi-threaded application. And this part is the profiling tool. Okay? Now, this profiling tool consists of 2 components. One is the front end, that is the UI tool, and the second is the back end. Now, back end is nothing but the PASOE application, okay, which is running on top of the OpenEdge database. Now, you could have this back end running on the separate machine. So all these 3 pieces could run on a separate machine. Or you could have this profiler tool running on the one machine, and your application is on the separate machine. Or all the 3 could be run on the same machine. So this is various configurations that this tool provides. Now, this tool will run in the 2 modes. Okay? First mode is active mode. So what will happen in the active mode, your profiler tool, that from the GUI tool, you will instruct the processes which are running on the ABL side that go ahead and start profiling. Once this instruction is given to these processes, they will start feeding the profiler snapshot data directly to the backend application. So they will be having a consumption URL. These applications will straight away put that data to this backend tool, which will get stored into the database. And later on, you will be using this profiler tool to analyze that data. So that's the live configuration. So the runtime, you are configuring the things. The other configuration is the passive configuration. In this mode, what you will be doing, you will be starting your application with the startup parameter that is profile memory. And there you will be providing the configuration file that tells that once I create a snapshot, where should I go and put that snapshot? The other configuration it will take is how often I should go and take those snapshots. So those 2 configurations you are providing in the configuration file. With that configuration file, this processes will start configuring, start profiling your application, and they will start the snapshots and the configuration file. Those are the OEMP file that we saw in the previous slides. Okay. Now, these OEMP files then will get loaded into the OpenEdge database, and then the things are same. You will be using the front-end tool to analyze the data. At present, we have only passive mode, which is actively passive mode in the system. So you will be starting your application with the startup parameter and collecting a data. You will put and then pull that data or load that data into the OpenEdge database or profiler tool and analyze that data. So this is what you will be doing when you are analyzing your application. Okay. Now, let's see, once you load the data into the profiler tool, what kind of visualization you will be having with that tool. Basically, this tool is for the developers. So when you are developing your application, you will be profiling your application, then get the profiler data, load that profiler data to your profiler tool, and then later on analyze them. Let me straight away go to the screen. So these are the various mock-ups that I'm showing to you, that when you analyze your data, this kind of information you will see in the profiler tool. Okay. So here, when you load OEMP files to the profiler tool, it will divide the entire memory into 2 parts. It will show you the breakup of your memory. How much memory is being consumed as a platform memory, that is /BT/D all the platform memory that you have configured, and how much memory is being consumed by the application object. So one is your application data, other is the profiler. And later on, if you want to dig down a little bit, you can see that out of this all memory, what memory is from which objects. So it says, okay, what this type of object are being created and that create at this point of time, and this is the state of those. This is the state of that type of objects. This tool will be having a feature that once you load your entire recording, you will say, okay, from time this to time this, so it's my starting time, this is the ending time. During this period, what's happening in my system? What are the live objects in my system? So it's okay, during this time, you have this type of large object in your system. So however, this is the largest object that you have in your system during this time. And the other thing that says, okay, these are the most instances of the object. So it's okay, this is the largest as well as this object as X has a maximum instances in your system. So this kind of reporting will be provided as a part of this screen. The next that we have is that if you go to the next thing, this after summary, if you go to the next screen, it will say that this type of objects, how much is the consumption of that memory. And if I click on that object, it will show me the detail about that object. Let me go one step. So I say that during that time, I have this OABL object. If I click on the OABL, this type of object, assume that this is the connection object. So okay, I have created the connection. These are all the different types of, this many instances of connection I have. If I click on that connection, it will show me, okay, you have these 5 connections with you. And if I click on any of the connection, it will tell me that in my call stack, where I have created that connection. If I have OABL object, okay, it will tell me, okay, these are the various object instances that you have, and in your stack frame, or in your call stack, where that OABL object is created. So this kind of detailing that you will be having. First, you will be having entire total picture that this is a platform memory, this is the application memory. If you go one level down, it will say that, okay, these are the various types of object that you have. If you go one level down, this type of object has how much, this instance has how much memory to it. I may have a one OABL object that it has 5 bytes of memory. The same another instance that I will be having, it has a 20 byte of memory. Now, where this 5 byte object created in my call stack, where this 20 byte object is created in my call stack. So that kind of detailing that we will be having. So the initial question that where have you spent my money? So this will say where you have spent it, where you are consuming your memory. The detailed information you will be having that in your application, these are the places where you are consuming your memory. Later on, when you have the snapshots, so we took a various snapshots, snapshot 1, snapshot 2, snapshot 3. So you want to see what is the difference between these 2 snapshots. So you can load those snapshots in the system and compare what's happening in my system. So in our case, we had a pre-snapshot, after snapshot, and the done snapshot. Load those snapshots in the system, and it's okay, this call object is created between pre and the after. So you know where in the system, during when we took a snapshot, where these things are happening, or where I should look for some problem. Okay. The next thing that it will give you is that suppose you have developed your application, you run the profiling, and you have one recording of your system. Okay. You found the problem, and then you have fixed that problem, and you have another recording of you fix the problem, and then you have another recording. You need to verify that the problem has been fixed. So you will compare these 2 recordings and see that what is the memory footprint of these 2 records. Whether it is optimized in memory, that's a memory leak related thing. Suppose with the memory profiler tool, you are trying to analyze what is the footprint of my memory in the various objects. You have some algorithms with which you have created your application, And you analyze, okay, this is not the proper way of architecting or working with those objects. You re-architect your, you modify your modules, and then again you run the tool. You run your application with the tool, and you compare these two runs. So this snapshot comparison is for the lower levels of stuff, and the recording comparison is for the higher level stuff, how the overall system is operating with the previous setting and the new setting, with the previous algorithm, with the new algorithm, without the bug fix and with the bug fix. So this way you will be analyzing, it will help you to analyze your system. So that's the initial content of our presentation. When we generally give this presentation, we get this sort of questions. Okay? So will the memory profiler work with all the OpenEdge releases? The answer is no, it won't work with all the releases. Wherever we have this support in the system, only that. So at present, 12.8 has the basic support for the memory profiler tool. So if you have a 12.8, you can start your system with the dash profile memory. It will generate OEMP files. 12.8, you can create the snapshot in the system, and you'll get the data. Okay? So with the 12.8, you will be getting some memory-related information in the system. With the releases, upcoming releases, we are providing more and more memory-related objects in the profiler output. The next question is, what is the overhead of using this memory profiler? Okay. From our testing, we have found out 9% to 7%. If you have been there in the previous presentation from a Progenode, when they are running this in that production, they have roughly reported 5% of overhead of running their application with the memory profiler tool. Will the profiler tool with the CPU? Yes, we wanted to do it, but not in the initial release. Are we sharing the profiler output file? Yes, we will be sharing. So once we officially release the product, we will be providing the information about what is the content of the OEMP file. And we will be tracking a .NET. Yes, we will try to, but that's not the promise. Because the .NET memory, each individual component about .NET resides somewhere else. So those are the basic questions we generally get when we present this thing. If you have any other question, I'll be happy to answer them. Yes?
The web pages, are they available now or not yet?
Not yet. We'll be providing once we officially release this thing.
Those web pages can run in my local development area, or? Also, the question is, I have a bunch of production servers, and I don't want to open, because of securities, for example, ports to the database or for this collection, to the servers. So I want actually to get those files to my, that the server sends it to me. And then I want to analyze it in my local environment. That would be possible?
Yes, that will be possible, yeah. Yes?
In general, we detect how big the problem of memory is whenever we go to load testing or into production. Can you use the profiler in load testing?
The question is, can I use the profiler tool for the load testing part? Is it? Yeah.
And detect memories on performance, like I simulated load I'm supposed to receive in production, and will be able to detect the memories through usages of one.
So if I understood the question correctly, can I use the memory profiler tool in my production environment?
Not maybe in production, but maybe in staging or pre-production.
Yes, you can use that part. When we start talking with the Progenode, they are using this thing in the production environment. So yeah, pre-stage development environment, you can try it out when you are developing application pre-staging. The ideal case, you will run, before you deploy in the production, run it in the pre-staging so that you don't have to go and run in the production environment. So yeah, you should ideally run your application in the pre-staging environment with the profiler before you go for the production.
And in this dashboard, I will be able to see who was the client who created this object?
Yes. So if you are running the PaaS application, each snapshot will be having a request ID within it. So with the request ID, you will be getting from where the request is coming. You can map it over there from where this request has came. And with that, you can map it with the client, from which client has created this request. Yep. Yes?
Will the profile be available for the Pro Win32 also, or only for 64 bits?
So basically, when you are running all those things on the server, at present we don't have this, we don't have an answer of this question, but mostly it will be on 64-bit only, 32-bit in between.
As I understand, now description of the profiler generated file format is still not available, but when it's be released, the file documentation and descriptions be available.
Yes, we will be providing what will be the format of OEMP file.
And also consequent question, or it's available pre-access to the file format description.
Pre-access?
Or early access. That's how it would be called. Test access to the documentation. If you buy the Progress product, we have tech support, we have the enterprise license, or we having access to that still not released documentation.
No, I think we will release it once we finalize. So it's product management's decision.
Do you have a published date already in view?
No, all those questions are the project management's decisions. So one thing I can assure you that we will be providing you the format of the OEMP file, but when that question will be answered by the project management. Whenever we go for the release at that time, we will be providing this information. But we will be providing the format of the OEMP file. Any other question? Yeah. Thanks for attending this session. If you have any follow-up question, please reach out to us. Thank you.